Hello, everyone. Thank you for being here. My name is Omer Aviv. I'm CTO and creator of Ozcode, and I wanted to say thank you for joining us today for this very special and very exciting presentation. Today, I'm excited to host Michael Shpilt, who's a lead developer and team lead here at the Ozcode team. And Michael will show us advanced techniques for production debugging based on his fabulous new book, Practical Debugging for .NET Developers. I'm really excited that we're going to be sharing all this fabulous, very, very practical content with you today that you'll be able to apply tomorrow when you go back to work. So without any further ado, I'll let Michael take it away.
Hi everyone, my name is Michael Shpilt. I recently published a book called Practical Debugging for .NET Developers, and a lot of the stuff we're going to go through today is from this book. You can find me at my blog, michaelscodingspot.com. So today we're talking about production debugging. It's a topic that's very interesting to me and specifically and to us at Ozcode. Why is production debugging so important? You all know this intuitively, but let's put it into words. So it directly hurts the business. If we have a bug that some of the deals in our e-commerce site don't go through, then it directly hurts the business. We lose money. If some coupons don't give a discount or give too much a discount, it directly hurts the business. If our site is unresponsive and so on. But also it indirectly hurts the business, because if we have little bugs, like it might be UI bugs and the things that make our site or our product look unprofessional, then our customers lose trust for us. Because now in modern times, our users use Gmail and use Apple products and use all kinds of stuff, and they're used to a very high quality software. So if we have performance issues and lag, unresponsive, whatever, then we don't look as good, and those customers might not want to continue using our product. Hard to debug. This is a big one, and we'll get back to debugging production. Let's talk a bit about what kind of problems we might have in a production. We might have failed requests. We send some kind of HTTP request or something else. It fails on the server side. We don't get a response. The operation doesn't go through, the deal, whatever. We might get crashes. Our IS server might crash. Our desktop application might crash. We also might have logical bugs. These are bugs that don't end in an exception. It might be some kind of wrong calculation. It might be incorrect behavior, like we get to screen A instead of screen B. We might get hangs. Now, hangs in a desktop application are very obvious. When you have a hang, the window doesn't move, it's frozen, nothing reacts, your mouse clicks, your keyboards, and in a server, in an ASP.NET application, it's a bit more subtle. When you have a hang in some kind of request, then that request doesn't return a response. Eventually, the client will probably time out. But because we have a bug that causes hangs in a request, more and more threads will become stuck on our ASP.NET application. And eventually other requests, even though they are not buggy, will also be unresponsive, will hurt performance until the entire site becomes unresponsive. Now, in these cases, IIS might recycle the application. It will restart everything. All the threads become free. All the requests that were hung will return a 500 or 503 server error, and the whole thing starts over again until we have more hangs and more stuck threads and so on. Memory issues. We might get an out of memory exception because our memory keeps rising and rising until the application finally crashes. We might have memory leaks. So memory leaks cause all sorts of problems. One of them is high memory consumption. But also, when the garbage collector doesn't collect objects and there's code in those objects that keeps executing, you might have wrong behavior. And also memory leaks can cause memory pressure. And that means that the garbage collector works more than it should. It takes up a lot of execution time, and it hurts performance, which leads us to the final issue, performance issues, which are caused by hangs and memory leaks, as said before, but they might also be slow database requests or a lack of cache or all sorts of problems, slow network requests. So going back to why production debugging is so hard. This is the issue, the most important topic in this webinar. For our foremost tool when dealing with production environment is logs. But logs is far from a perfect tool. For one thing, when you're looking at log files, you rarely have just the right log that you need and just the right information that you need. You might not have the right local variables or the right value in cache or the right execution line of the log. Maybe you need to add more logs in some kind in another method. So you add more logs, you deploy a new version to production, then you wait for the bug to reproduce again, read the new logs, and then you have some more information, but still not enough because now you find out that you need more logs in the other place, and so on. And that's the best case scenario. The worst case scenario that you didn't even find the relevant logs. Because say your customer says, I had an issue yesterday at this time, something didn't work. Now you have a bunch of logs. You have to look for just the right log with that customer, and it becomes like looking for a needle in a haystack. So logs are infinitely better than nothing, but it's a pretty hard world to live in if you just rely on logs. Now, okay, so maybe logs aren't enough and you decide to reproduce locally. But reproducing locally is pretty hard, as many of you probably know, because you need just the right circumstances and just the right application state that happened in production. You need maybe the right local variables, the exact user, the exact application state, the exact cache that was just in the right time. And maybe it doesn't reproduce at all locally because you need an application that's in scale, that has a very high throughput. So reproducing locally is always very difficult. Now let's say that you want to go hardcore, you want to actually attach a debugger to your production environment. And that's also easier said than done. For one thing, when you attach a debugger, when you stop on a breakpoint, the server isn't responsive, it doesn't work. It's currently in break mode, it's paused. And that's a big problem. If you can afford it, if you can attach a debugger and stop your server for a while, then in order to see the source code and be able to debug properly, you need to match symbols and the exact same source code version used to build your production environment. Even if you change even a single character in the source code and recompile locally in your dev machine, and then open a dump file or try to attach to a process in production, it won't work. You won't be able to see it. So and the other thing, the other big issue is that when you release to production, you release optimized code. If you when we work locally, we're using the debug profile. When we publish to production, we're using the release profile. Now the release profile includes a checkbox that says optimize code in production, and that's most of it is JIT optimization. And it does all kinds of code manipulation. It inlines method, it inlines local variables, it changes code. The result is that you can't debug properly code which is optimized. Now, there are ways to overcome it, and we'll look at a couple of ways, but it's difficult. The whole notion is difficult. Finally, sometimes you just can't debug even if you want to, because your service might be short-lived. It might be an Azure function because it's serverless. It might be a Docker container that has a very short lifespan. So the bottom line is that production debugging is very hard. Oh, and that's a big one. I almost forgot: personally identifiable information. Suppose that you capture the dump in production, or you attach the process. Now, consider that maybe you work in a bank. Once you have the dump file from the process, you have the entire memory of that process at a single time. If you're working at a bank, it means you can look at all the credit card, social security numbers, account information that was in memory in that time. That might not even be legal in your organization. And it's a problem in a lot of organizations, if not most of them. Finally, we have deployment machines that are hard to access. For example, if you want to debug a desktop application, you have to contact the consumer or your customer and establish some kind of connection. Maybe you have your application works on an on-premise machine. It might be one of those huge printers or whatever where you deploy an application, and that machine doesn't even have access to the public internet. So you have to go with your laptop to the factory and physically connect to the machine. Finally, there's deployment targets like Azure App Service, where you can't remote desktop to that machine. You have just command line. So you can't use a lot of the tools you're used to. Here are some of the tools at our disposal that we can use for production debugging. Now, we have some tools like logs files, which we develop ourselves. We have our debuggers, Visual Studio, DnSpy, WinDebug. We have some OS features like performance counters, ETW events, and dump files. Some of those are not available on Linux or not available at all. Performance counters and dump files now have some sort of support with .NET Core 3 SDK, but it's minimal compared to what we have on Windows. Finally, we have various profilers, memory and performance profilers, APM tools, error monitoring tools. Well, we're not going to get into those, so I sort of go through them quickly. And we have production debuggers like Ozcode. And today we're going to use just the following. We're going to see how to use debuggers, dump files, Windows Event Viewer, decompilers, and the production debuggers. So let's see that in action. I have a small application here that unfortunately was deployed to production with a lot of bugs. Now, every day that it's in production, we lose hundreds of thousands of dollars because of those bugs. So let me show you an example. First of all, the simple usage is I enter some kind of price, and I can enter a coupon code. I can enter additional discount, let's say 15%. I can enter input and output currency. And when I hit calculate, it gives me the result. So far, so good. Now, let's say the output currency is euro. And let's say no discount at all. Let's calculate. And here we see an error. If I go to developer tools, I'll be able to see that there's a 500 internal server error. Now what? Well, we can actually do a lot of things. I can go to the virtual machine where this application is deployed. By the way, this is an ASP.NET Core 3.1 application with Windows Server 2016, and it works with IIS. And I'll show you one very quick technique that I like. If I go to the event viewer, many of you probably know this application, and here in the Windows Logs application, every time there's a failed request, ASP.NET logs it to the Windows Event Viewer. And what I like about it is that you don't need any kind of setup, it just works. Open it, and in a matter of seconds, I have a lot of details. Let's see which details I have. First of all, I have the request path, basically the URL of the request that failed. Then I can see span ID and trace ID, which is used for open tracing. We're not going to get into that. And here is the most important piece of information, the exception details. Here is the exception type, argument exception, requested value, the exception message here, requested value EUR was not found, and the call stack that led to the exception. Now, I'll show you a little trick. I can copy the call stack here, and I can paste it to either Visual Studio with ReSharper or Rider. And as soon as I open Rider, I can see here the call stack. Now, I didn't prepare this. This wasn't here before, but because it was in the clipboard, then Rider shows me this information. Now, most of it is methods from the BCL, from .NET Core itself, but I look for methods in my namespace, in my project. And here I see there's the method calculate. Of course, I have to have the project that was in the same with the same call stack open in Rider for this to work. And here in calculate, you see if we go to the call stack, we see the next method is get currency from string, and we can see it's called here in both of those lines. Now I can go get currency from string. And then I see the next method is enum.parse, which means the exception happened in enum.parse. And if I go here to currency, you can see it's spelled euro, spelled EURO. And in the exception message, we saw that EUR was not found. So this is a pretty easy way to find the bug. It doesn't always work. It's not always enough information, but in many cases, just the exception details is enough. So the event viewer, the upsides is that you don't need any kind of setup in advance. You quickly see the exception details. Historical information is available. For example, if you encountered some kind of exception, now you want to go back to see how many times it happened in the last week or in the last 2 weeks, you can easily do that with the Windows Event Viewer. Well, not easily, you have to go through a lot of lines of logging, but you can do that. And it doesn't disturb server runtime. The server keeps serving requests, and that's a big upside. The downside is that you have little information. You don't have local variables. You don't have HTTP requests. You don't have contextual data of any kind, well, except for open tracing. It's not available in Linux. If you're using something like app service where you can't remote desktop to, theoretically, Event Viewer has a command line interface, but you probably don't want to use it. There are easier ways to get that information. So going back to our application, let's just move this back to US dollars, and I'll enter some kind of coupon code and hit calculate. See, the server takes quite a lot of time to process that. And eventually you see this page. And this means that the application pool, the IIS application pool is probably down, maybe because of a crash. Going back to the virtual machine, I'll just refresh the event viewer here. And you can see there are 2 more events that happened in the last minute. And here you can see it says the process was terminated due to an unhandled exception. Something regarding SSL connection could not be established. Now, let's say I want some more information this time. The call stack and the exception details are not enough. So one of the things I can do is to capture a dump file. A dump file contains the entire memory heap of the process, and we should be able to see that information. So let's do that. And there are many ways to do that, but I'll show you the way I recommend in these cases, which is by using a program called ProgDump. It's a free program, part of sysinternal tools, and you can download it if you Google it. And ProgDump allows me to write the following command: ProgDump exam. Sorry, it's 64-bit process of ProgDump 64 -ma says take a full memory dump. We always need a full memory dump to debug .NET processes. -e means monitor unhandled exceptions. And whenever there's a crash, it means there was an unhandled exception. We'll talk a bit about it later on. W3 WP. And yeah, so apparently IIS wasn't able to recover from the crash. So I'll just reset IIS and I'll go back to make sure that it really works. Yeah, the application responsive. So here we go. And now ProgDump is monitoring for unhandled exceptions. Let's cause an unhandled exception then. In other words, let's cause a crash, some kind of coupon code. Let's see if it reproduces exactly this way. Here we go. So ProgDump says one dump was created. And you can see in this folder that the dump file indeed was created. 400 megabytes of dump file. It's a very small application, by the way. Now, I already did the same thing, so there's no need to copy to a development machine because I already did it before. Actually, you can do several things here. You can copy to development machine with Visual Studio and debug with that, or you can copy WinDebug to this machine, which is a relatively lightweight tool, and debug with that. Now, WinDebug has been around for a while. It's a command line debugger. It's pretty powerful, but it's also very difficult. You need to learn a lot of commands. You need to some kind of boilerplate code, investigating variables and getting information from this application state is pretty difficult. So I don't recommend it. If you have a choice, don't use WinDebug. Sometimes you don't have a choice, but in any case, so I'll open Visual Studio and I need to open the same project of the application that I'm debugging. And here, while I'm in the solution, I'm going to open a file. And I already have a dump here. And here Visual Studio tells me some general information about this dump. It's a 64-bit process and loaded modules and stuff like that. I can debug it either with only with managed code, with both managed and native, and just with managed. I'll debug just with managed. Here we go. So here we can see a bunch of information. First of all, we can see the source code and the execution line where the exception happened, which is really an invaluable piece of information. Besides that, if I go here to locals, I can see the local variables. Of course, I can also see the exception details. I have it here under $exception, or I can use it here. I can go up in the call stack and see the local variables here. I can go to threads and whereas here is my thread, I can go to a different thread and debug it there, see the local variables in there. So it's just like as if I stopped on an exception in Visual Studio. It's a great debugging experience. The thing is that I really made my life easy here. This is not a real case, real world scenario. Why isn't it a real world scenario? So for one thing, the source code that's on this machine is exactly like the source code in the production environment. Usually you deploy to production and your source code is completely different by the time you see the bugs, because you develop new features, you work on the project and so on. Uh, in order to see the source code, you'll have to go back in history to the exact same git commit. And even if there was one character different than the one in production, it won't work. Now, and the other thing that I'm cheating with is the optimized code that we mentioned before. In a real world scenario, the code in the production would be optimized, and then some of the local variables, in fact, probably most of them would be not available. You'll see a red error line saying they were optimized away. That's because many of the local variables no longer exist. The JIT compiler either got rid of them or it can't map them to the local variables you see on the source code. Now, and also you usually won't be able to see the execution line. Again, for the same reason, because the JIT optimization, it changes code and Visual Studio doesn't know which line of the optimized code is relevant to the line in the original source code. So both of these things can be dealt with. There are technologies like SourceLink, where you can embed in the symbols in the PDB files the link to the Git commit that was used for that DLL or for your production environment. And then Visual Studio integrates automatically with SourceLink, and you'll be able to see the source code from that commit version, which is very nice, but it's a bit of a pain to set up. And about optimized code, it's you'll have to restart the process with the code not being optimized. And there are ways to do that also. It's a bit more difficult, and it's also not always practical, because you want your code to be optimized. It makes the code faster. Anyway, so here, dump files, the upsides that you can see local variables and the entire memory heap. By the way, that's something I didn't mention. One of the best things about dump files is that you can open it with a memory profiler like .memory or memprofiler, and then you can see all the objects currently in memory. You can see the state of your cache. You can see payload objects, whatever. And this part doesn't need all the stuff I said. It doesn't care if your code is optimized or not. It doesn't care if you matched symbols to source code. And it's great for all sorts of kinds of bugs. Now it can show the source code and the last execution line. Again, if you match symbols to source code and the code is not optimized, and it doesn't disturb the server runtime, which is a big one. The downsides is first, either you install Visual Studio to the production machine, which is probably not practical. You don't want to do that usually. Or you copy it to your development machine, open with Visual Studio. Then you need to match symbols and source code and deal with optimized code. All of that is hard. Finally, it's convenient mostly for crashes and hangs. It's not very convenient for failed requests. It's not convenient at all for logical bugs. For failed requests, actually, there's a way to capture a dump file on a failed request, but it's difficult. You can do that with procdump by changing the command line a little bit, but it currently only works on .NET Framework. It doesn't work on .NET Core yet. Maybe they will fix that sometimes in the future. I don't know. So here we go. Now let's go back to our program. Let's see that our server recovered. Yeah, it seems to work. And I'll show you one more bug. There are many bugs here. Let's say the input currency is $200 or even 100, and the output is pounds. No discount, no coupon code. Let's calculate. Okay, so it says $100 is 128 British pounds, which doesn't make sense at all because £1 is now worth more than $1. And this bug didn't end with an exception, right? It's a logical bug. So now what? Again, there are several things we can do. I'll show you a program called DnSpy. It's a debugger. It looks and feels a bit like Visual Studio. I can go here to debug in menu, attach to process, choose the W3WP worker process. You can see it's core CLR, attach. Now, if I go to modules, I can see my project DLL, open it, and browse the files. Here, I happen to know where to place a breakpoint, and I can do it just like that. Now, note that what you see here is not the original source code. The original source code doesn't exist on the production machine at all. What you see is the decompiled code. And the magic of DnSpy that it allows to place breakpoints in decompiled code. And that's an amazing thing, in my opinion. And let's test that in action. $100, I'll do the same thing again. By the way, sorry, I didn't tell you, but please, I'll answer all the questions in the end. You can write them in the Slack channel. There's just a lot of things I want to cover, and we have very little time. So, okay, so let's continue. Anyway, you saw here, when I press calculate, the server is non-responsive. And it's unresponsive because it stopped on a breakpoint in DnSpy in the production machine. Here, we can see that it stopped, much like in Visual Studio. We can see the local variables. And I can use F10 and F11 to step over and into methods. So I debug just like in Visual Studio. Here there's a very suspicious method, currency converter.convert. Let's step into with F11 inside and do some step over with F10. Now we can see in the local variables that the price is 100. The input currency is US dollar, output currency pounds, exchange rate 1.28, and the exchange rate really is 1.28. 1 pound is worth $1.28. And then we are multiplying 100 by that exchange rate. So here's the bug. We either need to divide by the exchange rate, or we need the other way, the reversed exchange rate, right? 1 divided by 1.28. And I'll just detach the process here. All right, now DnSpy. Sorry, I forgot. I wanted to talk to you a little bit about crashes regarding the previous bug where we created the dump files. Now, what causes a crash? Any unhandled exception causes a crash. But now you might say that, wait, in my controllers, and I have a lot of exceptions, and I don't have catch clauses necessarily, and still they don't crash the application. They just cause a failed request with a 500 error. So the answer to that is that there actually is a catch clause. It's just not in your code. It's in the code of the ASP.NET framework. And that's called a user unhandled exception. So the same thing happens when you write task.run. When you have an exception in the delegate of task.run, it also doesn't crash the process. It's caught somewhere in the BCL classes and the TPL classes, and it just makes the task faulty. It doesn't crash. What does crash the process? When you use thread pool yourself with the thread pool class, or when you create a thread yourself with new thread, or when there's a catastrophic exception. And the catastrophic exception, even if you catch it with a catch clause, it doesn't matter. It will crash the process. Those are out of memory exception and access violation exception and execution engine exception and all those guys and Stack Overflow, of course, that we happen to dislike very much. Okay, so moving to DnSpy, the upsides is it provides a great debugging experience. It's absolutely wonderful. You don't need too much source code and symbols. It decompiles the code. The downsides, the biggest downside is it stops the server from working while you're debugging. True for every debugger, not just DnSpy. Not available in Linux. It's a Windows program. Or in an Azure App Service or anything that you can't remote desktop to. It doesn't have a command line interface like WinDebug. Okay, so I'll show you one more tool. And actually, before even starting this talk, I installed Ozcode's agent on my application. And I didn't touch it. I didn't touch it at all. All I have is this screen when I created it, and it says here success, agent is up. Start debugging. Okay, let's see what happens. Okay, so in this dashboard, we can see all the errors that happened in the application in the recent month. Okay, and we had just 2 errors, right? We had here the crash. If you remember, the exception message was the SSL connection could not be established. And we had the failed request. Also with the euro, requested value EUR was not found. And what Ozcode allows me to do is I can click the debug button here. Let's start with the failed request. And I can see, I can see a lot of things. The middle part of the screen, it shows me the code at the time of the crash. This is the execution line that caused the crash. If we go up, we can see the methods of all of the entire call stack. And also, I can actually see the local variables in this method, in all of the methods in the call stack, really. So basically, it gives us the same thing DnSpy or a dump file with Visual Studio would give us, except that with Ozcode, you don't have to deal with anything. It captures exception automatically. It doesn't require you too much symbols on source code, and it doesn't require you to deal with optimized code. Okay, so far we have the same amount of information we have from Visual Studio and from DnSpy, but Ozcode gives you a few more things. For example, I have this logs tab here. And this logs tab, it shows me 1,000 of the latest logs that happened before the exception, until the exception happened. And those are logs from all the popular log frameworks. They include Log4Net, Serilog, Nlog, Microsoft Abstractions Logger, and System Diagnostics Trace. And if you're using some kind of custom logger, you can also consume Ozcode's NuGet package and integrate with that. So that's extremely useful because you can correlate the exceptions and the log messages. And this toggle button here, this shows the logs from the current from the HTTP context that ended up with the exception from the current request. Those are usually the most interesting logs. Now I'll show you here in the failed in the crash that we saw. We also had an HTTP request. If you see here, we have that HTTP GET request to coupon service or something like that. And this ended up with an SSL could not be established exception. And we can see up here in Ozcode's timeline feature, first we can see the incoming HTTP request, right? That's the post that we ourselves used. And you can see the request headers and the request body, including all the stuff from the form, the price, the input currency, output currency, coupon code, and so on. And also I can see outgoing HTTP requests. And this happened to be the request that caused the problem in production, where I can also see the URL, query parameters, request headers, and so on. So Ozcode provides a great debugging experience. No need to deal with matching symbols and source code or optimized code. Doesn't disturb server runtime, which is a big one. Latest logs, HTTP and database request details. By the way, if we had a database request, then we would be able to see information from there as well, including SQL queries. Allows to use all the other tools you're used to. So even though Ozcode was installed all this time, I could still use DnSpy, dump files, Windows Event Viewer. They can work in parallel. PII reduction, that's a big one. I actually didn't show you that, but Ozcode has a feature, and I have a screenshot here, that it has an automatic rule set that whenever it sees a credit card or a social security number or password or something like that, it automatically reducts that information. You won't be able, the developer won't be able to see that, and you can add your own rules. For example, if you have a class that's called secure account and you want to redact that, then you can add that class to Ozcode, and Ozcode won't show local variables from that. And if you have an entire DLL or an entire namespace that you want to show, for example, if you have namespace bank.secure, right, and you don't want to show any local variables whatsoever from that namespace, you can add it as a rule, and Ozcode won't show it. Okay, so Ozcode is right now free with some limitations, but you can start for free with all of its features, and it's very easy to set up. So let's compare a bit all the techniques that we talked about so far. We talked about the event viewer, we talked about dump files, we talked about DnSpy, and we talked about Ozcode. Now, this table here relates just to failed requests and to crashes. We also we didn't talk much about logical bugs, although event viewers and dump files don't help you with that, but Ozcode will. I'll talk about it in a second. Anyway, so we talked about showing exception information, and although all of those tools can show exception information, and in many cases that's enough to solve the problem. Stopping server activity. We saw that DnSpy stops server activity. Showing local variables. Some tools can show them when the code isn't optimized. Showing source code. Again, you need to match symbols and source code with dump files, but both DnSpy and Ozcode can deal with that. Showing the exact execution line. And then we have features that are available only in Ozcode, like showing latest logs, show HTTP requests and database queries that led to the exception. That's just in the same HTTP request, and PII reduction, which is a huge deal in many organizations. Now, what I showed you about Ozcode is sort of half of the picture. The other half of the picture is the ability to use something we call trace points. And I'm not going to show you today, maybe in a couple of webinars. But here, Ozcode allows to place sort of breakpoints that don't break, or lock points, if you will. And you can place a breakpoint anywhere in the code from the Ozcode browser debugger, enter some kind of message that includes local variables, and then each message also captures a snapshot. So when clicking on that snapshot, you'll be able to see the code and the local variables when this happened. So that's just briefly about that. All right, cool. So thank you very much. We have some time for Q&A, right? Yeah.
Yes, we do. And Michael, you have a bunch of questions waiting for you on the Slack channel. So, and there's quite a lot of them. So I'll help you out by reading some of them to you. So let's start with this great question from Dvir Segal. Dvir asks, what do you do when you don't have access via the internet to the production machine since it's located in a closed network? How do you cope with those types of situations?
So you can you'll have to debug somehow on that network. So either you ask your customer to give you some kind of information. For example, you can ask him to send you log files. You can ask him to go to the event viewer and send you export the events and send you via network. Same with dump files. You can ask him to capture dump files and send you, or you can install Ozcode on premises in his private network, and then he'll be able to see all those things. Or finally, you can always physically go to his premises and attach your laptop and try to debug this way.
Awesome. We have another question here from Pascal. Pascal asks, can the Ozcode Production Debugger be used to debug a WPF application as well? And how does that work?
Sure, absolutely. So Ozcode can capture 4 types of errors. Now, it can capture errors from crashes, as we saw, which is very relevant to WPF. It can also capture first chance exceptions, which are basically handled exceptions, which is also very relevant to WPF. And it also, the final thing is logged exceptions. Whenever you place log.error in your own code, even you can use whatever logging framework that you want, Serialog, Nlog, whatever. Ozcode also captures that, and you'll be able to see the local variables and the code from that point.
That's awesome. So we have another question here from David Clark. David asks, will the Ozcode Production Debugger work on an Azure web application or app service? And how does that work? How do I get that installed?
Great question. So yeah, Ozcode works, and it's probably the easiest way to install Ozcode. It's just an Azure extension. If you go to the Azure portal and extensions, just find Ozcode in the list, install, and it's up and running.
That's great. And so we have a question from Jorge here who asks, in your book, do you describe all of these tools or do you focus only on Ozcode?
Oh, I actually have relatively little focus on Ozcode. In my book, I describe all of those tools, and also I talk about the other kind of problems we might have, performance problems, hangs, memory issues. So everything that's related to debugging, and it's actually Ozcode is there, but it's a relatively small part.
Are awesome. So we have another question here from Rami. Rami asks, you mentioned that catastrophic errors such as out of memory exceptions, etc., cannot be caught in user code. So how do I deal with them? How do I mitigate that risk?
So a catastrophic exception inevitably leads to a crash, and then you debug it like any other crash. Whatever tool you're using, you can find out the call stack. You might be able to find out the execution line where it happened, and figure out if it's an out of memory, for example. Then a good policy would be to open it with a memory profiler and look at whatever consumes the most memory. It will usually be one type of object. It's usually a memory leak. It's always a memory leak in these kind of cases. And then just figure out why it's still in memory.
Awesome. So we have a few more questions here. And keep them coming, by the way, guys. Aaron Richter asks, can you use the Ozcode Production Debugger in a Kubernetes environment, specifically using Docker Linux containers?
Yeah, absolutely. And you can do that. It's a simple simple addition to your Docker Compose. And And we'll actually have a webinar about that in a month. So tune in and you'll see exactly how to do it there.
Awesome. So Igor asks, that trick you showed where you can automatically parse the stack trace of the exception, does that work out of the box with Visual Studio?
No, that's you have to have either ReSharper. If you're using Visual Studio, you have to have ReSharper or use Rider.
Awesome. And we also have a community input here. Devere adds that there's also an extension called Stack Trace Explorer that you can get from the Visual Studio Marketplace, even if you don't use ReSharper, which basically does the same thing. So that's very cool. Awesome. So I think we're just getting to the end of the questions here.
Well, there's one more in the Q&A, and Van Zadelhoff asks, where is Ozcode running? Do you have to install IIS? And the answer is no. It works with whatever .NET configuration that you might have, including self-hosted .NET Core apps and the desktop application and anything you can think of .NET.
Awesome. So Stahl, and forgive me if I mispronounce your name, Stahl, asks, can it debug or decompile C++ CLI code as well?
No, Ozcode is just .NET for now.
That's true. I'll tack two more things onto that, since it is a question that we got from a few other people in terms of what languages do you support. So right now, Ozcode only supports .NET, but we support the various multitudes of what .NET means. So we support Windows, Linux, .NET Core, .NET Framework, all of the different constellations of .NET, both on premises and in the cloud. We do plan to support many other languages, including Java, JavaScript, TypeScript in the near future. And you'll hear more about that from us in the coming year. Lastly, to Stahl's question there, it will work for you in terms of if your call stack has a mix of C++ and native and managed code, meaning both C++ and C#, you'll still get a debugging experience. You'll still be able to debug your C# code. You just won't be able to decompile or debug your C++ code through the production debugger. Now let's see here. There's people are still typing in their questions, and I'll use this moment to tell you guys that the Slack channel that we've opened here is yours to keep. So it's a great way to reach out to Michael even after the webinar is over with your questions and feedback. I'll also be there to answer any questions. So any sort of debugging questions, share your thoughts with us, share your debugging concerns, your grievances, and we'll do our best. We'll have a bunch of debugging experts on there to help with anything you can think of asking us. So let's see. Peter asks, do you support F#?
No, we support just C# for now. And probably the next language that we will tackle. And Omar, stop me if I say something I shouldn't. But
No, go ahead.
We'll probably go with Java and Python as the next languages.
So, alrighty. So I think we're just running out of questions here. I'll once again let you know that the Ozcode Production Debugger is a great tool that you can try out right now. Simply go to app.ozcode.com, sign up. Very easy to get your agent installed, and we'll, of course, be there to support you with any questions you have along your journey. Debugging. As Michael mentioned, non-breaking breakpoints or trace points are coming very soon. So watch out for that. And it is free to try for one agent, so nothing to keep you from trying. Oh, we do have one question that Veer asks, how do you cope with situations where the code is obfuscated or using some or encryption or various techniques that are meant to make it unreflectable and undebuggable?
Yeah, so in this case, it's probably the decompiled code will just be much harder to read than you'd expect. It will still work though.
Awesome. So we have another question from Roy here, who asks, what are the actual resource requirements for the Ozcode debugger?
Yeah, so by resource requirements, do you mean if whether Ozcode consumes a lot of resources? If that's the question, then Ozcode does have a slight performance overhead up to 3%, although it usually doesn't reach that level. And we have an automatic throttler that dynamically checks our performance. And if we go beyond the 3%, then it automatically stops some of the instrumentation and keeps the performance at that level. We never go beyond 3% performance overhead.
That's a great point, right? Because the Ozcode Production Debugger basically works in a very similar fashion to how an APM tool works, right? It's using bytecode instrumentation. And that's what allows us to turn that instrumentation on and off willy-nilly as we go and employ that self-throttling mechanism that enables us to give you this great debugging experience, but without hampering performance in any sort of meaningful way, so that you can put it on your production environment without any worries. We have more awesome questions coming in. So Jorge asks, if we have several environments like QA, perf, do we need different licenses for each one? So I'll take that one. So the pricing model for Production Debugger is per agent. So if you have a QA machine or a perf in a different environment for perf testing, you do need to buy an agent seat per machine, per host, essentially. And that's another really interesting point that question sort of leads into, in that the Production Debugger, while we call it the Production Debugger, is actually a fabulous tool for QA and staging and integration environments. So quite a lot of our customers are actually using it the most in their QA and staging environments, and getting a ton of value out of doing that, just because that's where they have the most bugs, right? Hopefully. So we have another question for you, Michael, here from Roy. Does it need a lot of free disk space, since it did not seem to only work live, but it has to keep that state somewhere somehow?
So the agent itself is very lightweight. I don't remember how many megabytes exactly, but maybe 20 megabytes or something like that. And when it's working, it's part of the process that you're. It's part of the process of the application, and the RAM that it consumes. Well, I think Omar, why don't you answer that?
Right. So in terms of RAM consumption, the performance overhead of Ozcode Production Debugger is very, very negligible, specifically because it does not use dumps or lightweight memory dumps or any of those technologies that other products might use. So you will see a completely negligible performance impact in terms of your memory consumption. Awesome. So let me run through here. I think that we're out of questions, which is awesome. But I will remind, I think we managed to address everybody's questions one by one, which is really great. I will remind everyone that even after this webinar is over, the Slack community that we started here is not over. It will be the same community with the same awesome folks that have joined us. And we will be, readily available to you guys to answer any questions, whether questions on the content of this webinar, questions about Michael's book, question about the Production Debugger. And we'll also be using the same Slack channel for our follow-up webinars, such as the next will be on the topic of debugging microservices and .NET Core running on Linux. So with that, without further ado, again, this is me, Omer Aviv, saying thank you so much, Michael, for this awesome presentation. One last question that we should not forget. Greg asks, where is the book URL? So the book, Michael, you can maybe share your screen and show your website for folks that are interested in the book. I'll tell you right away that it's practicaldebugging.net.
Yeah, thanks. Great question. Practicaldebugging.net here.
Awesome. So with that, thank you again, Michael. Thank you, everybody, for joining us today, and we'll see you on the next webinar. Have a great day.